Hello, I'm Mr. Klingler, and today we're going to talk about inclined planes. Imagine I have a block resting on a frictionless inclined plane. What's it going to do? Well, clearly, it's going to start sliding down the incline. In fact, the acceleration will be parallel to the surface of the incline. This is problematic. The reason is, that means we have acceleration in the x direction as well as the negative y direction. It's going to be hard to solve for acceleration in that way. It would be really convenient if the acceleration were to be along one of the axes. So, let's redefine the axes. To do this, we will create a parallel axis and a perpendicular axis. They are parallel and perpendicular to the surface of the incline. My perpendicular axis, my parallel axis. Alright, that's convenient. Let's look at the free body diagram associated with this block. If we were to draw forces, we should recognize that there are going to be two forces. We will have a normal force, which will lie along the perpendicular axis because it is perpendicular to the surface. We also have the force of weight. I would note that what causes us to accelerate down the axis is the force of weight, but not all of the force of weight. Only part of the force of weight is actually moving along the axis. Like we do with diagonals, we need to break this up into components that lie along the axis. So, one component would be force, weight, perpendicular. The other component would be force, weight, parallel. It strikes me that this angle is related to this triangle. How are they related? Well, it's quick to find out. That's 90 degrees. Therefore, this must be 90 minus theta. If this is 90 degrees, that means this must be theta as well. If that's theta, and this is my triangle, I now have an expression for FW and for all of these. Great! We now have a strategy for solving problems. Let's try it. Let's find the acceleration of this 100 Newton block. Imagine the angle is 36.87 degrees. Alright, let's give it a shot. First thing I do is I draw a free body diagram. I often find it convenient to draw my axes on a diagram like this in order to remind me of what I'm doing. Well, I clearly am going to accelerate in the parallel direction, so let's write an equation for it. The force of weight is helping me down the incline. What part of it? The parallel part. Any group of forces is equal to ma. I know an expression for force of weight parallel, and now I simply plug in. Please note that in solving this, I assumed this was a positive direction. Furthermore, notice that the masses cancel out. It wouldn't matter what this value was as long as the plane was frictionless and no external forces were acting. Let's try one more problem. Let's find the force push given this triangle. Okay, I notice that I'm accelerating up the incline. I wonder what's happening. First thing to do, draw a free body diagram. I note that we're going to be talking about the parallel direction again, so I write a sum of the forces equation in the parallel direction. In the parallel direction, I have two forces. Once again, this direction is positive for me. Any group of forces is equal to mass times acceleration. Force of weight parallel is Fw sine theta minus the force of push. All right, now I need to start plugging some values in. Let's see what we have. A is -2 because it's in the negative direction. What should I do about theta? Because I'm not given an angle. Well, I could use trig. I know 5, 12. I could use tangent to find this theta. Or I could recognize that this is a perfect triangle. 5, 12. This side will be 13. So I could just use the ratio of sides. I need sine. So if that's the angle, it would be 5 over 13. All right, solve for F push. And I get there. Regretfully, I didn't bring my calculator, something you students wouldn't forget to do. So I can't solve it any further than this. I hope this was helpful. Good luck.